In the last class, we discussed the network model and we discussed about the critical path method. We explained how we are going to draw the arrow diagram, how we are going to find the earliest start, how we are going to find the latest finish, how we are going to identify the critical path, what is the total project duration, how to determine the floats. How to determine the floats. This is what we discussed in the last class. Today we are going to discuss one more problem, but with a small change. The next level, but the same idea. Next level, but with the same idea, which is called project evaluation review technique. Project evaluation review technique. This, dear, when you are studying ISPM, Information System Project Management, when you are studying ISPM, you will study the same idea, but with a small change with respect to IT or IS requirement, with respect to IT or IS requirement. But here the same principle. Here what we are going to do now, let me give you an example. You know that very well, we are giving the homework or assignment, isn't it? The teacher is giving the homework. You know that very well, there are some students, they will submit the assignment or homework immediately. Maybe I am giving you an assignment. Okay, today is the 2nd of 2/11. You have to submit your homework or assignment on 10th. For example, I am giving you the date, 10th. So immediately what will happen? Some students, they will submit their homework or assignment before date, maybe on 8th, maybe on 7th, maybe on 5th immediately. Some students, they will submit exactly on 10th. Some students, they will submit exactly on 10th. And there are some students who will come at the end of the semester, teacher, sorry teacher, I forgot teacher, please help teacher, my assignment teacher, please take teacher. When they will come at the last day of the exam. So today there will be the exam, they will come and ask the teacher, teacher, please help, this is my homework, you did not give me mark, please teacher, help me teacher. Now we are having 3 different timings. We are having 3 different timings. The first one, when the students are submitting before time, then it is called optimistic time. If the student submits the assignment or homework before time, then it is called optimistic time. That is, the time will be taken to complete a task under extreme well condition. Extreme well condition. The second one, on the date, exactly submitting on the date. That is called most likely condition. That is a normal condition. Normal condition. The student, those who are submitting their work at the end, very late, that is called pessimistic time. That is called pessimistic time, under poor condition. The optimistic time is called T0. Most likely time is called TM. The pessimistic time is called TP. The pessimistic time is called TP. From this, we are going to find what is expected time. We are going to find what is the expected time. We are going to apply a rule, TE equal, the expected time equal T0 plus 4Tm plus Tp divided by 6. TE is nothing but T0 plus 4Tm plus Tp divided by 6. This TE is the time given in the previous model. This TE is the time that was given in the previous model. Once if I find TE, we are going to move on to the same critical path method and we are going to complete the same task. We are going to complete the same task. So here you have to remember the rule. If you remember the rule, the problem is solved. TE equal T0 plus 4Tm plus TP divided by 6. And then from this, we are going to find the variance. When you are studying statistics, you might have studied about the variance. The variance is nothing but sigma squared. The variance is nothing but the sigma squared equal Tp minus T0 divided by 6, the whole squared. Tp minus T0 divided by 6, the whole squared. You have to remember the rules, dear. Okay? You have to remember the rules. And if you remember the rule, you can complete the problem very easily. You can complete the problem very easily. Okay? I'm going to show you, or I'm going to change the slide, and I'm going to the sample problem where I have worked already, so that it will be easy for you to draw the diagram.
Doctor?
Yes, my friend.
Assalamu alaikum.
Alaikum salam, my friend.
Doctor, before midterm, we need a preview if you please.
When is your midterm, my friend?
Midterm of our subjects, inshallah, will be 11.
Yes, sir. So no
11.
problem. I will do one thing. Maybe in the next class, I will make the review. Okay.
Yes.
Or better to make it on 9th, the next week, before the exam.
Yes, before the exam.
One day before the exam. One class before the exam, I will make the review. I think that will be good for you.
Yes.
Okay?
Yes, good.
Dear,
yes,
I will make the review on 9th. Okay, I will make the review on 9th so that 11th you can write the exam. Okay?
Okay. Oh, thank you.
Thank you, my friend. Thanks a lot. Now I am going to share the next slide. See, the question will be like this, dear. A project has the following characteristic. The project has the following characteristic. Job, we are having 1 to 2, 1 to 6, 2 to 3, 2 to 4, 3 to 5, 4 to 5, 6 to 7, 5 to 8, 7 to 8. The list of activities are given. The corresponding optimistic time T0 is given. The most likely time Tm is given. Pessimistic time Tp is given. Please remember, always the optimistic time will be the smallest number. Most likely time will be some middle number. Pessimistic time will be the biggest number. Optimistic time is the smallest number. If you have something in the opposite, maybe by mistake in optimistic time you are having a big number, then the whole answer will be wrong. The whole answer will be wrong. That is the reason why I am telling you in advance. Remember, your optimistic time T0 should be the smallest number, or maybe equal. All the three numbers may be equal. That is no problem. Or any two numbers may be equal. But it is the order. Optimistic time is smaller than the pessimistic, most likely time is smaller than the pessimistic time. Here they have given all the values for each activity, 3, 6 and so on. Now draw the question is that draw the network, calculate the length and variance and critical path. Length, variance and critical path. Let me delete the last one because in online you may feel difficult. Okay, let me keep only the two questions. Draw the network, calculate the length and variance of critical path. Now, what we are going to do now in step 1, we are going to find the expected time and variance. We are going to find the expected time and variance. How to find this? How to find this? Let me delete 2, 3 and I will explain you how to do this. Okay. Here, first we are going to find the expected time TE for the first activity. For each and every activity, you have to find the timing. I am going to check what is the rule for TE. For TE, the rule is T naught. For TE, the rule is T naught plus 4Tm plus Tp by 6. And I am going to check what is the rule for variance. For variance, we have given the rule that Tp minus T naught the whole squared by 6. 1 second, my friend. Doctor, I am in the class. So for variance, we have given sigma squared is equal to Tp minus T naught divided by 6, the whole squared. So now I am going to find the value for TE for the first one. This is equal to, I am going to check, oh, I cannot insert an equation now. I thought. Okay. How to make it now? Dear, because as I am unable to insert the equation here, I am writing here, dear, on the top. Okay. On the top, I am writing here for the each activity and we will upload. Okay. For activity 1 to 2, for activity 1 to 2, we are going to insert the equation. What happened? The equation is just give me a second, dear, because the equations is not working. Give me a second, 1 second, please. Okay. I will do one thing there. Sorry, give me a second. I'm copying the documents to another Word document because this word is not working. Okay, then we will continue. Just give me a second, dear, please.
Okay, doctor. Okay, take your time.
Dear, can you see the Word document now? Okay. See here, TE. I'm going to find TE. Just I copy pasted to the new one, dear. Okay. So that I can insert the equation here itself. Okay. Now, what I am going to do now, we are going to find the value of TE. We have to find for each activity. We have to find for each activity. How to find this? I am going to apply this in TE, T naught. I'm going to apply the rule. T naught plus 4Tm plus Tp divided by 6. What is the value of T naught? The first value is 3. The second value is 6. So 4 multiply 6 plus the third value is 15. Just I'm taking the numbers as it is and I'm going to use the calculator and I'm going to simplify this. I'm going to simplify this. 3, the first value is 3. 4 multiply 6 plus 15 divided by 6. Now using the calculator, I am going to simplify this. 3 plus 6 4s are 24 plus 15. 42 divided by 6. The value is 7. The value is 7. In the same idea, I am going to find the next value. For each activity, we have to find the values. Don't forget, for each activity, we have to find the expected time. We are going to apply the same rule. There is no change in the rule. We are going to apply the same rule. TE is nothing but T naught. What is the first value T naught here? What is the value of T naught here? 2 plus 4 multiplies the second number. What is the second number here? 5 plus I am going to check the third number. What is the third number? 14 divided by 6. Divided by 6. Again, using the calculator, I am going to simplify this. I am going to simplify this. It cannot be in point. Okay, let me check. So this is 2. 4 5s are 20 plus 14. 36 divided by 6. This is 6, dear. Correct? The second value is 6. The same idea, I am going to find the next answer. Can anyone find the answer and tell me for the third one? Please find the answer. If you have the calculator, please find the answer. This is 6 plus 4 multiply 12 plus 30 divided by 6. Use the calculator and tell me the answer. Can anyone? This is 14. This is 14. Okay, this is equal 14. Understand the idea, dear? 6. This is 4 to 8. 8 plus 1, 9 plus 5, 14. In the same idea, we are going to find the values for all the activities. We are going to find the values for all the activities. Using the same principle, we are going to find the values of all the activities. Understand the idea, dear? So in the same way, we are going to find the next one, variance. We are going to find the variance. I am going to apply in this here. Here there is no M, only P and naught. Tp minus T naught divided by 6. Tp minus T naught divided by 6. So I am going to apply this in the rule. What is the value here now? What is the value of Tp? The value of Tp is 15 minus value of T naught is 3 divided by 6. I need to find the whole squared, isn't it? We have to find the whole square. So using the calculator, I am going to simplify this. Using the calculator, I am going to simplify this. So somebody gave the answer, I think. Let me check. This is 4. Excellent. Excellent. Yes, this is 4. The value is 4. In the same idea, I am going to find the next value. In the same idea, I am going to find the next value. This is 40 minus 2 is 12. 12 divided by 6, 2. So this is 4. I'm using my calculator, dear. Okay, I'm using my calculator. The same idea. What about the next one? 30 minus 6, 24. 24 divided by 6. This is 4. 4 4s are 16. 4 fours are 16. In the same principle, we are going to find the values of all the activities. We are going to find the values of all the activities. Everybody understand the concept here, how we are going to find? Just we are going to use the rule, apply the rule, find the answer. Apply the rule and find the answer. Now, once if you finish this, we are going to check for the network. We are going to check for the network. How we are going to draw the network. How to draw the network? Our idea is nothing but I am going to take the values from each one. What are all the values given here? I am going to check only the activity 1 to 2, 1 to 6, 2 to 3, 2 to 4, 3 to 5, 4 to 5, 6 to 7, 5 to 8, 7 to 8. So I am going to draw, first I am having 1 to 2 and I am having 1 to 6. So I am going to take the node 1 and from 1 I am going to draw two lines, 1 to 2 and 1 to 6. The next one I am going to check. The next one is 2 to 3, 2 to 4. That means from 2 I am having two activities. From 2 I am having two activities. One is from 2 to 3 and another one is 2 to 4. One from 2 to 3, the another one is from 2 to 4. I am having two activities from 2.
Doctor?
Yes, my friend.
You know, just yesterday, Dr. Salah teach us about critical path. And he teach us also burst node and merge node. About this one.
Yes.
Just yesterday in IS.
But that will be little different way, my friend. That's what I told you. In ISPM, you will study with respect to the project management schedule. Okay. Here you will discuss in advanced way. Okay. The same principle, but the advanced way. There it will be very easy.
Inshallah.
Okay. Here this will be little advanced model. Okay. The next one, I am going to check 2 to 3 and 2 to 4. The next one is 3 to 5, 4 to 5. So from 3 and 4, I am going to draw two nodes. From 3 and 4, I am going to join to 5. I am going to join to 5. The next one is 6 to 7. Till now, we were having here 6 to 7. I am going to draw a node. Then I am having 5 to 8 and 7 to 8. Please remember, always you have to complete on the same node. Always you have to complete on the single node. You have to start at one point and you have to finish in the same point. Now we are going to find. See dear. Now we are going to find the earliest start and the latest finish. If you remember, yesterday in the last class, I put this thing. One, I put this one for earliest start. For each activity, we have to add the earliest start. Dear, don't write anything on the board. We have to start from 0. We said we are going to start from 0. Then we will be keep moving for each area, isn't it now? We will be keep moving for each point. Here I am going to check the value of each activity. What is the expected time? Here we are going to take the expected time. 1 to 2, the expected time is 7. 1 to 2, the expected time is 7, isn't it now? So this is 7. I am going to check the expected time for the next value. What is the next value? 1 to 6 is 6. Then 2 to 3 is 14. 1 to 6 is 6. So here I am going to take 6. And 2 to 3, it is given 14, isn't it? What is the value of 2 to 3? I am taking the expected time for each of the activity. Expected time for each of the activity. What is the third value, dear? Is it correct? 6 plus 4 multiply 12 plus 30 divided by 6. This is 14. Divided by 6, this is 14. So 2 to 3 is 14. 2 to 3 is 14. Next, I am going to check the next time. 2 to 4 is 5. So 2 to 4 is here. I am going to take the value for 2 to 4 as 5. So I need to bring it to the next line. 2 to 4 is 5. Then the next one, I am going to check the timing. The next one, 3 to 5, 11, 4 to 5, 7, 3 to 5, 11, and 4 to 5, 7. So I am going to write here 3 to 5 is 11, and 4 to 5 is 7. I am going to take the corresponding expected time. 4 to 5 is 7. The next one I am having for 6 to 7. What is the value for 6 to 7? 6 to 7 is 11. 6 to 7 is 11. So in the next value, I am going to take 11. The last two values, 5 to 8 is 4 and 7 to 8 is this one. So 5 to 8, here I am going to take this is 4. 5 to 8 is 4. And here they have defined 7 to 8 is 18. 7 to 8 is 18. Now, using this expected time, we are going to find the earliest start, and then we are going to find the latest finish. Dear, for our convenience, I am taking the bracket here because we may get time loss. So I am going to use the bracket for every place instead of drawing this diagram. Okay, triangle and rectangle. So from here, I am moving to 2. From here, I am moving to 2. So what will be the value for 2? When I come to 2, the earliest start will be 0 plus 7, the value is 7. 0 plus 7, the value will be 7, isn't it? So I am taking them in the bracket here. Instead of making them the triangle and rectangle, I am taking them in the bracket. So from 2, I am going to reach 3, and from 2, I am going to reach 4. Now I am going to check the value at 4. I am going to check the value at 4. Here the value is 7. I am going to add the expected time. The expected time is 5. So 7 plus 5, this is 14. 7 plus 5, the time is 14. I am going to check the time for 3. I am going to check the time for 3. So when I want to check the time for 3, here I am having 7. Here I am having 14. Here I am having 14. So 7 plus 14, the value will be 21. The value will be 21. Understand the idea, dear everyone? So whenever we are moving for the first value, we are going to add the numbers. Now here I am going to find the value for this. Here I am having 0 plus 6. When I reach 6, the value will be 6. When I reach 6, the value will be 6, isn't it? Now I am going to check the value for 7. I want to check the value for 7. When I want to reach 7, here I am having 6. Here I am having 6. Here I am having the expected time is 11. So 11 plus 6, this is 17. 11 plus 6, the value is 17. The same idea, we are going to reach the next point here, because for each one we are going to find the expected time and this one. But when we come to this point, when I want to reach 5, I am having two methods. Either I can reach from 21, 3 to 5, or I can reach from 4 to 5, isn't it? I am having two methods. Either I can reach from 3 to 5, or I can reach from 4 to 5. So I am going to check the big number, because we said we are going to check the maximum when we are coming from the first. We are going to find the maximum when we are going to coming from the first. So I am going to check the values. Here I am having 21 plus 11. Using the calculator, I am going to check directly here. So 21 plus 11, this is 32. When I come here, this is 14 plus 7, this is 21. So the big number is 32. So I am going to take the value as 32. I am going to take the big number, which is 32. Understand the idea, dear? Now finally we are going to find the value at 8. But when I want to reach 8, I am having 2 points. One is 7 to 8, one is 5 to 8. I am going to check the maximum of this. When I want to reach from 7 to 8, the value is 11 plus 18, 29. 11 plus 18, this is 29. And I am going to check the next value. 32 plus 4 is 36. 32 plus 4 is 36. So I am going to take the big number 36. I am going to take the big number 36. So when you want to find the earliest start from the beginning, you are going to start from 0 and you are going to add the corresponding expected times. You are going to add the corresponding time from one activity to the other activity. When you reach the final point, wherever you are having multiple joins, wherever you are having multiple joins, you are going to take the maximum. You are going to take the maximum. So when I take from here 0, the value is 7. So 0 plus 7, the value is 7. 7 plus 5, my God, I made a mistake there. 7 plus 5 is 12. 7 plus 5 is 12. Here 7 plus 14, this is 21. 7 plus 14, 21. So 21 plus 11, 32. Here 12 plus 7 is 19. So the big number is 32. I am going to take the big number 32. So when I want to reach the last point 8, I am having two values. One is 17 plus 18. 17 plus 18. One is 32 plus 4. So what is 17 plus 18? 17 plus 18. The value is 35. The other one 32 plus 4. The other value 32 plus 4 is 36. So the big value is 36. I am going to take the value as 36. Understand the idea, dear? Everyone? Now the section will finish. Please re-log in again. We will finish the problem today. I'm going to close this one. Please re-log in again. Use the same credential. Okay? Because the time is going to finish. Please log in again.